In the last video we were talking about exponential growth, and I got a problem here that I ran out of time to do. So welcome to the next video. Let's do this problem. We have a world population mid-year 1950, about 2.56 billion. So I think that's going to be my initial condition, P naught. During the period from 1950 to 2000, world population increased at a rate that doubled the population approximately every 40 years. Find a formula that estimates the mid-year population from 1950 to 2000. Using the formula from Part A, estimate the population mid-year 1955. Okay, so let's assume 1950. Let me swing my computer around here so I can write a little better. Let's assume 1950 is time 0. Okay, so when t equals 0, that's going to be my 1950. Very important. If you don't do that, it muddies up the equations. So let me go with, so to get part A, let's see, part A here says find the formula. So we're going to say P of t equals my initial condition there, 2.56. Alright, and this thing is going to double. Is that what it says? It doubles every 40 years. Alright, so I want to hit it with a 2 in 40 years. So to do that, I need 1 over 40 times t. Now really think about that, and that should make sense. That is, when that t is 40, I get 1 over 40 times 40, and that gives me 2 to the 1, so I hit it with a 2 and I double it. So that gives me the formula. Part B, let's put yellow. Part B here. Using the formula from Part A, estimate the world population mid-year 1955. Okay, if 1950 is my time 0, for that is t equals 0 at 1955. T equals 0 at 1955. I mean, t equals 0 at 1950, then 50, 51, 52, 53, 54, 55. 55 is going to be t equals 5. So that's going to be P of 5 equals 2.56 times 2 to the 5/40th. So let me just go 1/40th times 5. So that's going to equal 2.56 times 2, and 5, and what's 4? 40 is 8 times 5, I believe. So it's going to be 1/8. 2 to the 1/8. And we're going to get an approximate answer here. 2.56. We'll clear it out. 2.56 times 2 raised to the 1/8. Oops. And extra parentheses. I don't know if it locked that or not. So about 2.79. Let's go with that. This will be about 2.79, and we're in billion, so about 2.79 billion. Okay, that is at 1955. Let's state the answer there. Therefore, in 1955, the population was approximately 2.79 billion. I like doing this because I think it sets a good example for you to actually state your answer. Okay? So in 1955, the population was approximately 2.79 billion. Let's look at another problem like this. Here's one. We have a colony of bacteria starts with 100 cells. So I believe that's going to be my P naught. That's always that initial condition. And triples. So triples in size every 4 hours. Find a function that models the population growth of this colony of bacteria. Let's do that first. Part A. Let's go in that color. So we're going to get P of T equals the initial condition 100. That's my P naught times, and we're tripling this time. We're not doubling. So to triple something, I multiply it by 3, and I want to multiply it by 3 in 4 hours. So that's going to be 1/4 T. Again, really, it's so much better if you try to think about why this is true rather than just try to memorize the formula. I mean, this makes sense that when I put a 4 in here for T, 1/4 times 4 is 1. Thus, I get a 3 there, and I get to triple something. Okay? So I think that's going to be my formula. Approximate how many cells we're going to have in 6 hours. So B is simply going to be P of 6. P of 6 equals 100 times 3 to the 1/4 times 6. And that's going to equal 100 times 3. 1/4, so 4 is 2 times 2. 6 is 3 times 2, so that's going to leave me with 3 to the 3/2. Right, where we wrote that is 2 times 2, and the 6 is 3 times 2. That 2 cancels that 2 and leaves me with 3/2. And again, this is going to be an approximation here. Let's see what we get. 100 times 3. 100 times 3 raised to the 3/2. 519. So let's say 520. About 520. So about 520. And again, I want to state my answer to set the standard here. Therefore, after 6 hours, doubles over 4 hours. Okay, after 6 hours. So after 6 hours, there will be about 520 cells. Okay, and I think that's going to do it for this video. Stick around, because in the next video we're going to start talking about how money grows, and everybody needs to know how money grows. Peace.